everybody. I'm going to do a demo on page 605 in your book. And it is basically finding two different volumes of two different figures that are just kind of pushed together and then adding them together. Ariel is thinking of a three-dimensional figure that is made by combining two rectangular prisms. What is the volume of this three-dimensional figure? Solve any way you choose. So volume equals length times width times height. And when we find our answer, we know we have to do cubic units because it's 3D. Here we have centimeters, so we know that our answer is going to have cubic centimeters as is going to be our label. So there's two ways you can do this, because right here you see it looks like it's all one piece, but we have to turn it into two pieces. So you can either, let's see if I draw a line here, now I have like a small sort of a square looking figure and a big tall one in the back, maybe like a large Kleenex box in the back and a small short one in the front. Or if you want to, you can think of it this way. Let me see how my skills are here. Boom, boom, boom. That there's like a big brick on the bottom, right? And then maybe a smaller Kleenex box on the top. So you decide which way you want to do, however you visualize this. Do you visualize a big one in the back, small one in the front, or long one on the bottom, short one on the top? So when I visualize this, I visualize it both ways, but I want to do mine this way. Okay, so first you choose that. And if you want to get something you have around the house, like let's say a tissue box, and like there's not tissues in there, and a Bible or something, just so that you can picture, okay, there's my figure, and I'm going to pretend that this is it, so that you can look at the numbers on here and kind of actually take a piece away and be like, okay, this is the back one, so it's 4 centimeters across, 2 centimeters towards me, 7 centimeters down. If you want to just take a couple items in your house to do that, might help. Okay, so for my back box here, length times width times height. Okay, so this is like a top base, right? There's bottom base down there somewhere. So the top base would be like the length times the width. So 4 centimeters times 2 centimeters. So I'm going to do like shape number 1, which is this big one in the back. I'm going to say that. We have 4 centimeters times 2 centimeters. So volume equals 4 times 2. So length times width times height. How tall is this big box in the back? 7 centimeters. Okay, so volume equals, and you multiply, you can multiply these two first, you can multiply these two first, however you want to do it. I want to do 4 times 7 because I know that's 28, and then I just have to double it. So I'm going to do 4 times 7 is 28, times 2, 8 and 8 is 16, 56. Okay, so 56 centimeters cubed is how big this one is. Figure number 1, okay? Let's say this one's figure number 2. So we're going to do the same thing here. Volume equals length times width times height. So let's see. Well, see this 6 right here? That means this whole thing is 6, which means this little piece right here is less than that. So what can I do to figure this out? Well, if I look up here, this is 4 centimeters, right? And that's the same as this side's 4 centimeters, this side's 4 centimeters. Oh yeah, and if that's 2, that must be 2. So you have to do a little figuring out here. So, and if this side's 4 centimeters, the top right here is. So the base, which is here, 4 and 4, 4 times 4 are the length and the width. So 4 times 4, length times width, or length times width, times height, which is 2 centimeters. All right, 4 times 4 is 16, times 2 equals 32. So the volume of figure number 2 is 32 centimeters cubed, or cubic centimeters. So the question is, what's the volume altogether? So then I just add these two up. 6 plus 2 is 8, 5 plus 3 is 8, and I get 88 cubic centimeters. Go ahead and log into Envision online and watch a video for page 606, or there's actually a few videos on there. And then I want you to do number 5 and number 6 on page 607. So you have a choice to make. You could, when you're figuring out which two figures are you going to calculate the volume of, you can do this top one and this bottom one, or maybe if your eyes are seeing it differently, you could draw a line here and figure out this volume plus this volume. And then for number 6, same thing. Do you see a tall figure standing in the back that you're going to figure out the volume for, and one in the front? Or do you see a big long one on the bottom and a shorter one on top? Your choice, okay? So length times width times height for each of the figures that you pop out of here, and then add them together, and we'll have cubic centimeters here and cubic feet here. So cm3, ft3 for your labeling.